Alrighty, what it do, E-World, Crisscrossing Wires, back with another video, and we're working on my RZ. About to change the controller out, and yeah, I'm joking, that's not the controller, that is actually my step down, and yeah, rather decent size step down at that. It's 45 amp, but yeah, this is the controller that I was running. It is an ASI BAC 8000, and in my opinion, and maybe some other guys out there, uh, this is one of the best controllers they ever made. And I say that because of its hardware and not just the software, which a lot of people don't like, because you have to have specific access to get to certain things. But even still, there's third-party apps like Kilowatt and GLE that make it pretty easy to do basic tuning and setups. But as far as the hardware in this controller, ASI was always a premium, expensive brand as opposed to others when they first came out, and still even now in some circles, this is a $1,200 to $1,300 controller, depending on where you get it. And if you get like a GLE, it may even be more because you get variable regen and all that with GLE integration. Now, reason why the hardware is so good on this controller, for one, it's not American made, but it's made in Canada, so it has really good components. If you ever watch a teardown video of this controller in comparison to something like a far driver or something else comparable in the same power class. Now, don't get me wrong, far drivers are great controllers. You get a lot of bang for the buck with those. But back to hardware aspect and the build quality, this is a much better built controller. It uses better components, better MOSFETs, better capacitors. Just overall setup is better. The power stages are better designed and better built. Whereas though, like the terminals in a far driver, they're just soldered, and you can actually over tighten them and they'll pop right off the circuit board in a far driver. Whereas though these have a physical connection, they're actually bolted to the PC boards. It's just, same way with anything custom or quality, the way it's constructed is better. Now, a lot of guys will disagree, mainly guys that aren't into the real technical aspect of it, and they'll say ASI is junk, they burn up and all that. And the truth of the matter is, a lot of times they're not even burned up. Actually, they go into protection. I've seen where some people call it the blinking red light of death because the LED is blinking. And that doesn't mean it's dead. It just means it has a fault. And a lot of times it's a fault that some of those guys aren't able to clear, so they think it's dead when it's not. Now, if you were to burn up one of these, it would be for the same reason that you could burn up any type of electronics running high power, and that is from overheat. Heat is electronics worst nightmare. I mean, heat destroys all electronic components. Now, what happens a lot of times, people run these controllers with no heat sinks. Now, ASI does make heat sinks for these controllers. They're rather expensive, and most people don't actually buy them. They run it without one. And if you were to flip this over, it's just a aluminum bottom to it that's flat and smooth, and it really doesn't have any way to dissipate the heat other than the surface area. Now, a heat sink, I actually I didn't purchase a heat sink from ASI. I actually kind of DIY'd my own, because you can literally buy a heat sink in different sizes and shapes, or have it cut to a size. If you notice, don't know if you can see, but there are fins. That's an aluminum heat sink, and it covers the entire length of this controller. And those fins allow air to flow through there and keep it cool. So if you didn't have a heat sink, this controller is subject to overheat. Like with any controller, they get hot, especially in the summertime. Far drivers have water cooling systems where you can buy a section of aluminum that has piping and slots in it that you can hook up a radiator water pump that pumps coolant through it to cool them down. And like I said, once again, high power is going to create heat and inefficiency. So if you have an inefficient system, or a system that has to fight against a lot of resistance, that too is going to create heat. I also have, on the heat sink, I have a fan mounted to it in the center, up underneath. So when I power the bike on, the fan actually blows air through those fins and keeps it cool. So I never had a problem with overheating. Okay, so yeah, I just want to say that. Now, as you can see, I had 0 gauge phase wires because originally when I set this bike up, I was planning to change the motor on it. And the reason why I have 0 gauge, because I like a lot of current flow. And what I did was I was using this distribution block. So I had 0 gauge running down to this distribution block. And then the stock motor, I had changed the phase wires and upgraded them to 8 gauge. And they connected at the distribution block. Now, obviously it's not as good if as having 0 gauge from the controller all the way to the motor, but that's impossible. Can't run 0 gauge into that motor. But the closer I could run it to the motor, the better. So even because it didn't go all the way, it went close enough, so a shorter distance through those 8 gauge, it helped a little bit, that's for sure. And upgrading those 8 gauge, those phase wires in the motor to the 8 gauge also helped. I actually was able to get, as far as top speed, up to 80 miles an hour on this stock motor. Now this stock motor, it's a YM motor, but it's basically a really cheap, inexpensive motor. It has little tiny magnets, 30 millimeter I believe, or 35, a little small stator, so it can't handle a lot of phase amps. Although I did run 18 to 20 kilowatts as far as the line amps, I didn't run a lot of phase amps. I kept the phase amps down to a minimum. about 350 phase amps, and with 350 phase amps on 72 volts, I was able to reach 84, 85 miles an hour, which is pretty good, especially with about 200 DC line amps or 250, somewhere in there. Anyway, we're upgrading to this 12 kilowatt, and just on the same system for now, I'm going to keep it 72 volt just to see the difference in the, actual motors themselves, because obviously I can run that BAC 8000 at full power, which is 840 phase amps, and although that may not change the top speed a lot, obviously it'll be a little better, but increasing the phase amps and the DC line amps is going to increase the acceleration. So, while the top speed may be in the same vicinity, it should get higher, obviously. But we're looking for a big difference, in 0 to 60 eighth a mile and quarter mile times. Because even with that 80 miles an hour, it took a little while for it to get there. Yeah, I mean, it did pretty good, but nothing like the beast, obviously. So, yeah, we're going to see how that works out with just changing the motor. And after that, then we're going to go ahead and upgrade to high voltage with a different controller. So that's pretty much it. As far as changing the motor, it's just not a straight swap out, because this dropout for this motor is a lot smaller than what the dropout should be for this larger axle. I measured this axle, and it's actually 24 millimeter when that one is 18 millimeter. So there's a pretty big difference in the overall circumference of the axle. But just as far as the slot, it's like 2 millimeter. So I really need to shave off 2 millimeter there, and I'll be able to get that motor in there. So obviously I won't be able to do that on camera, so I'm going to do that, either use my Dremel or Sawzall or whatever I have to use to open that dropout and slide that motor in there. So that's basically that. I wanted to give some type of tip as far as at least setting up your power ratings on your controller. And I tell people all the time, because most people seem like if they're going ahead and setting up their parameters as far as the power, they always just turn everything up to max. Whatever the controller's max line amps, they turn that up to max. Whatever the phase amps, they turn that up to max, regardless of how much their battery is capable of. Alright, so yeah, a lot of times that will hurt your overall performance. Actually, setting those levels to lower settings can actually give you better performance. And why that is, I'll try to explain it like this. Imagine you have a battery, basically a regular battery you bought from Alibaba, NB Power Pack, something that's not custom, not high output. Most of those batteries are capable of 150 amps, whether it be the cells capable of 150 amps or the BMS limited to 150 amps. Basically you get 150 amps. Now, if you have a 300 amp controller, right, and you set the DC line amps to max 300 and the phase amps to whatever the max is, 800 amps, When you go to full throttle, even on a full battery, because you're overloading that pack far beyond its potential, when you full throttle, your volts are going to drop from 84 all the way down to 70, maybe 68, 69, because of that huge current demand, and that pack can't produce it. So therefore, your controller, as far as it making power, and you know power is amps times volts, so you want the highest potential of each. You want the highest amps going to your controller at the highest voltage. Now if you full throttle and your volts are dropping from 84 down to 70, that's all your controller is using for power, is that 70 volts it's seeing. All right. At the same time, your motor RPM, the amount of RPMs is based on voltage. It increases with voltage. So the higher the voltage, the higher the RPM. The higher the RPM, the higher the speed. So if you're full throttle and your volts drop down to 69 volts, that is what your motor sees. And if you had set your power settings to which your battery could actually handle, and let's just say you set it at 100, 125 amps, 150 amps. So now when you full throttle, instead of your volts dropping from 84 down to 70, maybe they only dropping from 84 down to 80. So now your controller is seeing 80 volts and your motor is seeing 80 volts. Your motor is going to see a higher RPM, a higher voltage and produce a higher RPM. And your controller is going to make more power because it's seeing higher voltage. So, that being said, a lower setting would produce a better result. Overwhelming and, boosting all the settings up to the max isn't the best thing, especially if you don't have that power available. So you're really hurting yourself. You're tricking yourself. And that's a lot of people's mentality. Obviously, everybody thinks if you turn something all the way up, that's going to be the best. But no, not if your system is not capable. By you turning everything all the way up, your bike is running on lower values. I mean, that's the best way I can put it. You're going to get better. You're going to get more for less. When in fact, you're getting less by turning stuff up more. So, I hope you get that. And not only that, same thing goes for field weakening. Here's another great tip people don't understand. When it comes to your field weakening, you have to remember or understand that field weakening, in order for field weakening to work, field weakening is actually creating a force in the opposite direction that's counteracting EMF, which is slowing your motor down. However, that to create field weakening, it takes power. So field weakening needs a certain amount of voltage and its own amps. All right. So if you have your power level set to 100 amps, like I said, and you have your field weakening set to 50 amps, instead of just your controller needing 100 amps, it needs 150 amps. All right, 100 amps for the power output, 50 amps for the field weakening. All right. Yeah, so you got your at the same time, your pack has to be able to produce those amps for both. If you got everything turned way up, at that point, you're already getting lower results, and you don't even have effective field weakening. At that point, your field weakening is not even working because the amps aren't there. So set the field weakening and the power limits, the power output, to a point where it's not exceeding the battery. So 150 amp battery, set your DC line amps to 100 amps, 50 amps of field weakening. That's 150 amps altogether. Your battery can handle that. All right, so without that, it's not working. A lot of people say, well, I adjust my field weakening and it ain't changing nothing. Yeah, because you got everything maxed out. It's not working. It's not effective. So yeah, set everything to the proper amount of power that you are able to provide. All right. All right, so that's pretty much it. I'm gonna leave it there. It is what it is, and I'm gonna holler back at y'all later after I get that drop opened up. So that's it. Take it easy. Take care. Crisscrossing wires. We out. Peace. See you when I got this motor mounted.